I'm Glen Rabenburg from Soilworks, and I'm glad to be part of your South African Dryland Farming Conference. We're filming the first part of June at our shop in Bancroft, South Dakota. We thought it'd be fitting because farmer to farmer, we're not only a company, but we're also a research station that has almost 1,000 acres in South Dakota where we research row crops and small grain, as well as alfalfa and many other cereal grains. Bancroft, South Dakota, where our farm is at, is population 12. It's very rural. We're about 20 miles from nothing. And South Dakota is primarily agriculture. We're not famous, and we don't produce a considerable amount of anything, but we are very active in agriculture. The eastern side of South Dakota is predominantly flat and fairly arid. We receive anywhere from 14 to 20 inches of rain per year, and we doggone sure get winter. Our soil freezes, and it becomes unbearable on both ends of the thermometer. One of the reasons we're filming at the farm is the information, knowledge, and wisdom that we're going to present to you today isn't just something that we've thought of or heard in a conference or read in a book. We are real world, boots in the dirt, hands-on company that works on our just a little under 1,000-acre research farm where we grow organic corn, soybeans, and small grain. We also have our research greenhouse at our facility in Yankton, South Dakota, 2 hours from here. So between the greenhouse, the research farm, and all of the work that we do within the U.S., Canada, South, Central America, and across the world, we've learned by experience, and this experience has cost time and money. So before we get started, if I may, I'd like to ask a favor. A lot of the things that I'm going to talk about haven't been talked about by other speakers and other conferences. I am known in the agricultural industry as a disruptor. I challenge authority and I question the status quo. What do I mean by that? There's a lot of companies that are spending a lot of money to give information that financially benefits them, with you and I being growers not being the forefront. So just to set the stage, cute little story I want to start with. A friend of mine is a realtor in Minneapolis, Minnesota. And he made a big sale the other day. And on his way home, he stopped at a liquor store and went in to get a bottle of wine. And on his way out, he ran into a homeless person. And during the bump, the homeless person backs up and sees the brown bag and asks my friend, "What's in the brown bag?" And my friend smiles. He goes, "Oh," he says, "I had a real good day." And he goes, "I just got a bottle of wine for my wife." There was a 2-second pause, and the homeless person looked at my friend and says, "Good trade." Now, no hack on women. My point to this hopefully cute little story is many times what is said may not be heard. A lot of speakers that are on the circuit and university professors that are doing a lot of talking are controlled on what they say. These university professors are controlled by grants on what they can and can't say. So many times the whole truth and nothing but the truth isn't on the forefront of the talk. So if I may, I'd like to give you a short background on what it took to get to where I'm at today. Right out of college, I started with animal pharmaceuticals and biologicals, as well as nutraceuticals, minerals, and digestive aids and herbs and things like that. And while I was doing that, climbing up through the ranks, I got asked a question that kept reoccurring. Growers with dairies, cow-calf, feedlot, hogs, poultry, they'd say, "We're losing more animals than we used to. We're treating more animals than we used to. It's costing us more per pound of gain. You in the industry, animal health, animal pharmaceuticals, biologicals, say we're smarter than we've ever been. but our checkbooks don't show it. And then they look me right in the eye and go, why? And I'd have to take a big deep breath and look them back in the eye and say, I don't know, but let's find out. This is a very short version of a very long story. But what we decided to do is we started looking at nutritional mineral tags. A bag of mineral that you buy from a feed mill or a co-op lists the calcium, phosphorus, potassium, magnesium, and sulfur ratios in that bag. Basically, it was put together by a nutritionist for the longevity, immunity building, and production of an animal. So thinking the nutritionist must be right, I compared the mineral tag to a TMR, a total mixed ration nutritional analysis to see if they were the same. And what we found out is the feed that was being grown was completely upside down. It was completely wrong for the health and immunity building of these animals. So, being from South Dakota, I thought, hey, let's take a look and let's try to make the feed nutritionally look like the mineral tag. And with that, we'll see what happens. Long story short, the producer said, we don't have as many sick animals. We don't have as many dead animals. We're not needing as many antibiotics. Now, these growers were 7 different growers that we worked with for over 7 years. And what we found out is as the nutrition of the crop improved, we also noticed that the weeds, the disease, and the insect pressure of that ground that we were working on all of a sudden decreased. We're going to talk about soil, we're going to talk about plants, we're going to talk about a lot of things that you maybe haven't heard a speaker talk about, but we're going to talk about healthy soil, and we're going to talk about healthy plants. Now, keep in mind, many times when somebody says something, what is heard may not be what is said. When I say healthy soil, my definition of healthy soil is without disease or without impairment. What's an impairment? Compaction, erosion, lumps, clumps, clods, weeds, disease, problems that just start to show up in almost every farming operation. So when we're talking about soil, we're talking about healthy soil that can grow food, that can grow nutritious food, that doesn't need a pile of chemicals and doesn't have to have a high fertilizer bill. We're also going to talk about healthy plants. Healthy has the same definition, without disease and without impairment. And when we talk about healthy soil, when we talk about healthy plants, there's a difference in plants. If you were to ask many university professors in the United States, what's a weed? They would proudly take a big deep breath, lean into you and say, a weed is just a plant growing out of place. Being a disruptor, I disagree with that. It's growing exactly where it's supposed to because it's trying to correct a problem. But in today's society with the crisis management, oh no, there's a weed. Here comes the spray boom with the chemical. Whack. The scout that was trying to fix something and tell you a story of imbalance and unhealthy soil just got killed. Welcome to today's agricultural economy. Reacting to symptoms has become far too easy. The industries have made it very easy for us to just look what to kill. There's 1,000 ways to kill something, but there's only a few ways to bring life. There's only a few good ways to nurture health and to create immunity. But we can kill it 1,000 different ways. Let's take a look at bringing back life. If your budget consists of spending money on things that are in the air or reacting to symptoms, maybe a little tune-up is needed. So, with this topic, it's almost a sick joke that I can cover this in the short period of time that we have, but we better get to it because we've got a lot of things to do. So, the first thing we're going to look at is soil. When you have soil, you're going to want to do a soil test. And keep in mind, I'm in the U.S., so I'm going to go with inches and feet. You'll have to convert it into the metric system, and I apologize for that. Normally, a 0 to 6 or 0 to 12 inch in this country is used in the soil test. So when they go out and they pop holes in the ground and probe up all the samples, they mix it all up, they send it to the lab, and you get back your numbers, and here you go. Wonderful, fantastic data, but I'm going to tell you what it doesn't tell you. A soil test is fantastic, it needs to be done, but it's limited in the information that it gives you. We're going to cover the top 5 minerals, nitrogen, and then we're going to add some things that your soil test may not have, because we are looking at how to get water penetrating into the soil and how to actually sequester carbon from the atmosphere. So, if we have a carbon sequestration problem in the soil, something may not be right, otherwise the soil would be sequestering it. Kind of makes sense. So when we get our soil test back, it shows the calcium and the phosphorus and the potassium and magnesium and sulfur, and we're just going to do the top 5 for now because that's the first most important group that we work with. I'm going to give you the mineral. I'm going to give you its personality and also the job. Calcium, in my mind, is the mother of all minerals. And what I mean by that is calcium is the mineral that relaxes soil. Calcium is the mother mineral that fixes all boo-boos, the finder of lost things, the fixer of all things that go wrong, the creator, the nester, the environment builder that allows everything else to work. So I will name calcium as the mother of all the minerals. Calcium is one of the heavier minerals in the soil and naturally migrates down through the soil. So if you don't have air, if you don't have microbes to help hold that calcium up, you will find that in your soil test, whatever depth it may be, you will find that the top portion of your soil test may be deficient in calcium if nothing was left to hold it up. Now, if I talk about tillage, many people will squirm and say, oh boy, that's a bad word, that's a dirty word. Well, if I may ask another favor, if you're a dyed-in-the-wool, hardcore no-tiller, please sit back and open up your mind. Because the things I'm going to talk about, some of them you will agree with. That's good. There will be some things I will say that you will not really be too sure about. That's good. And there's going to be things that I will say that you possibly flat out disagree with. Now that's great. If you disagree with it, hopefully now you'll research it. All of the information that I'm bringing to you comes from statistical agronomic science, real world boots in the dirt work. So when I talk about calcium, we have watched it migrate down through the soil. If you're curious to see where your calcium is at, do a top 1, 2, or 3 inch soil test, and you will find out that the top 3 inches of your soil test virtually have no calcium in there. So calcium is heavy, it migrates down, and it wants to hook on to a lot of different things. Calcium is a mother, and if she's not in every portion of the soil, no different than a house. If when you were growing up as a kid, mom was down the basement and you guys were upstairs and you're having a fight, if she can't get to you, there's no discipline that can be administered. So if calcium is down deep, you're going to be having problems, and the chemicals and the fertilizer that's added many times is a reaction to a symptom. And rather than reacting to symptoms, we're going to talk about correcting the cause. And many times it's just a calcium deficiency. So calcium has to be in every cubic inch, every cubic centimeter, every cubic millimeter of the soil in order to do its job. So calcium, looking at the number that you have, it is what it is. We have to work with what you have. Looking at phosphorus. Phosphorus is the next mineral. Phosphorus I call the father of all minerals. Phosphorus is the worker. It's the carrier of all the nutrients to and through the plant. And together, calcium and phosphorus become the parents of the rest of the minerals in the soil. What's my point with this? If your parents weren't at home, there were probably activities that went on that never would have happened if your parents were there. Something probably got broke, someone probably bled, and then you scrambled to fix it before they got home. Calcium and phosphorus are the parents of the soil. If the calcium and the phosphorus isn't in place and isn't available, and that word available we'll get to in just a little bit, they're not going to be able to do their job. So, calcium and phosphorus, the parents, the strength, the base unit of the soil. The next three minerals are called the electrolyte minerals: potassium, magnesium, and sulfur. They're electrically active and they electrically tie up things. We'll start with potassium first. Potassium, being an electrolyte, loves to tie up water. And potassium will waterlog a plant and will gather excess water into that plant, lower the sugar content of the plant or lower the immunity level of that plant, and allow that plant to be more susceptible to disease, to insects, and to weed infestation. An excess of potassium is one of the bigger problems that we see. Now, potassium is also a substitute for calcium. Not a good substitute, but it is a substitute. If a plant is sending its roots out looking for calcium and can't find it, and it says, oh shoot, no calcium around, hey, there's some potassium. Pop, 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 pop. It'll grab it and take it in. Potassium, when it becomes in excess, increases the water content of that plant, and it dilutes the sugar content. And what I mean by sugar content is photosynthesis, the carbon cycle, all the wonderful things that Mother Nature and Mother Earth has been doing for years and years and years. With an excess of potassium, you get an excess of water, you get a deficiency of sugar. Photosynthesis is the plant laying its leaves out, gathering sunlight, water, and minerals to make sugar. This sugar is distributed throughout the physiology of the plant, and it's used to build microbes, to reproduce microbes, and also to grow the plant. Calcium and phosphorus are the two most important minerals needed for photosynthesis to happen. If you don't have available calcium and available phosphorus, you won't build sugar. You will not sequester water. You will not have water penetration. You will have a higher chemical bill. You will have a higher fertilizer bill. You will have more insects. So probably stressed that a little bit more than what I needed to, but available calcium and available phosphorus are needed for photosynthesis. So, calcium and phosphorus and potassium. Potassium is your electrolyte mineral that grabs onto water, and it loves water. The next electrolyte mineral is magnesium. Magnesium is an electrolyte mineral that loves to hang on to nitrogen. A lot of the fields that you guys are growing in may have a high magnesium spot. And what you will find is magnesium will grab onto water and hang on to it, and it'll hang on to it at a rate stronger than what the plant can exhibit. And magnesium, when it's in excess, also hangs on to nitrogen on a one-to-one basis. We're going to come back to some of these minerals in just a little bit, but I want to make a run through the first five so we kind of have an understanding of what the basis is. So magnesium ties up nitrogen and hangs onto water, and it makes lumps, clumps, clods, hard pan, plow pan, tight, compacted soil. If you have compacted soil, you have a magnesium toxicity. Now, if you're an Albrecht fan or a Neil Kinsey fan, fantastic, good guys. They did a lot of wonderful things for agriculture for many, many years. When they talk about base saturation, they say that you want 68 to 70% base saturation of calcium, that you want 12 or 13% base saturation of magnesium. What they may not have told you is the rest of the story. To tell the truth, the whole truth, and nothing but the truth. Let's just say that this book is a clay particle. And let's say there's 100 parking spots around this clay particle. Base saturation means they want 68 parking spots to be calcium. They want 12 parking spots to be magnesium, and so on and so forth. That's what is considered by Dr. Albrecht and Neil Kinsey, fantastic people, base saturation. Many times people think, well, when I achieve base saturation, I've hit the pinnacle of supreme balance, and that's all we have to do. It was named the base saturation for a reason. It's just the first step. It's just the foundation. It's just the footings. It's just the starting blocks of where things have to happen. So when you achieve 68% base saturation of calcium, 12% base saturation of magnesium, that's just the beginning. So let's say you have that accomplished. So we're looking at calcium and phosphorus being the parents, potassium and magnesium being two of the electrolyte minerals. Well, here comes the shy, quiet child, sulfur. Sulfur is needed for many, many different things, and many times it will just disappear on you. Sulfur can leach up or down. In contrast, magnesium and potassium, they really don't want to move much at all. Phosphorus will move laterally. These are all the personalities of these minerals. So with sulfur leaching up or down, we have to be very, very careful that we hold good levels of sulfur in the soil, and good levels are depending on the crop that you're growing. So as we look at this, sulfur is a mineral that can move up or down, can disappear from the profile, and it's also a mineral that when it becomes in excess will tie up calcium. Many times sulfur is overused to try to change or manipulate soil pH. And it is normally used unsuccessfully because sulfur, when it's in excess, will tie up 10 times its weight in available calcium. So many times you'll add sulfur or a sulfate to the soil, you will get the pH to drop, but all of a sudden the crop will suffer because the calcium has diminished. Now, when we start looking at tissue levels or soil levels, there's a parameter and there's areas that we look at to make this all work. More so looking at the actual mineral content in the soil, one of the things we have to look at is a soil test is a wonderful tool. But it's just one tool, and one tool doesn't make up a shop, and one tool can't normally fix things. This soil test talks about how much calcium, phosphorus, potassium, magnesium, and sulfur is in the soil, but it doesn't say if it's available. What's my point? When we look at the soil, when we look at the minerals in the soil, we have to look to see if they are available. How many times has your fertilizer man said, you got some phosphorus in the soil, you got quite a bit of nitrogen, but it's all tied up, or it's unavailable? Well, to me, that's unacceptable. If it's in your soil, why can't you use it? Why would you buy more if it's already in your soil? There's one thing that these minerals all need to be accessible by a plant no matter where they are in the soil. And that one thing that each and every mineral needs is quite simple. Take a big deep breath and think about it. Air. More importantly, oxygen. Let's take a look at phosphorus. Phosphorus is listed on your soil test as total P. P1, P2. But if you do a wet chemistry analysis, a tissue test, or a sap test, that phosphorus that may show up many different forms in your soil is only reported in one form and only one form on a tissue, wet chemistry, or sap test. And that phosphorus is always reported in P2O5. Phosphorus has to have a handful of oxygen to get from the soil to the plant. Sulfur is another wonderful example. Sulfur is for the soil, chemical symbol S. Sulfate is the only thing that the plant can take in. Sulfate, SO4. The chemistry doesn't lie, and oxygen is needed in order to have anything good happen within the soil. So as we're looking at your soil test, the mineral levels are all good, and I'm purposely not going to give you numbers on what your soil test mineral should be because that's been covered by 1,000 different guys for the last 50 years. What I am going to focus on is giving you the information that they didn't give you. As we look at the soil, a lot of South Africa has high magnesium compacted areas. You may have high calcium on your soil test, and your magnesium may still be a problem. What's the deal? Calcium's a mother, it should be able to handle it. But if she's not available, she can't stop the fight that magnesium plays in tightening the soil, in compacting the soil, allowing water to run off, and disallowing air to come into the soil. So as we're looking, whether it be water penetration, whether it be photosynthesis, whether it be a healthy plant, a good yield, a disease-free crop, or here's the big one, sequestering carbon, let's think about that. Sequestering carbon. We've talked about the top 5 minerals and really haven't gotten anywhere. We're going to jump into a different science here just for a little bit, meteorology. The reason we're going to talk about meteorology is because there's many things in the air that we got to get in the ground. And if it's not going from the air to the soil, something isn't right. So when you look at the pressure of the atmosphere, it's measured by the barometric pressure, or millibars. Millibars is the pressure or the weight of the air. Now, here comes the meteorology. Let's say there's a high pressure front, and a high pressure front is heavy sinking air. This air is designed to push into the soil. The barometric pressure, the millibars, are heavy enough to push into the soil. How do we know it's getting in there? If you're using chemicals, if your nitrogen bill has gone up, if you have insects or disease, you're not getting enough air to the soil. There's a tool, and this will add more information to your soil test than what you may realize. And the tool is a very simple penetrometer. The penetrometer is a very important tool, and as you'll notice, it has a fairly long shaft. There's a reason for that. The deeper this can be pushed into the soil at less than 200 pounds per square inch means a deeper, more efficient carbon sequestration. The further that air can get pushed down into the soil, the more air, the more microbes, the more carbon sequestration you have. The most important mineral that is needed for water penetration and carbon sequestration is available calcium in every level, every cubic millimeter in your soil. If calcium isn't there, you'll have tight soil. If calcium isn't there, you'll have weeds. If calcium isn't there, you're probably just like your neighbors. And what I mean by that is if you've been in a no-till or a minimum till situation, keep in mind calcium's heavy, migrates down. If you don't have microbes to digest that calcium and hold it in the profile, you lose it. Let's say you do a soil test and your soil test shows all kinds of calcium. What's the penetrometer show you? What do other indicators show you? What are other indicators of a calcium deficiency? Well, an agronomist, Jay McCaman, wrote a book, When Weeds Talk. Brilliant agronomist, and his research showed that almost every weed grows in the deficiency of available calcium, the deficiency of available phosphorus, and a deficiency of carbon and oxygen, all getting into the same circle of what we're talking about, the carbon cycle. If the air has nitrogen, which we know 78% of every breath of air we take is nitrogen, and we know there's over 400 parts per million of carbon, we have to get that carbon cycling into the dirt. So when you have available calcium, phosphorus, carbon, and oxygen, you will have weeds that naturally just disappear. This book, we have highlighted every weed that we've been able to extinguish. We've been able to desiccate. We've been able to do away with. We've been able to give last rites to these weeds with just making sure there's available calcium, available phosphorus, carbon, and oxygen, and having less than 200 pounds per square inch in the soil profile. Other than weeds, disease, and insects, there's other indicators to tell whether your soil is healthy. Looking at the last two elements of nitrate nitrogen and ammoniated nitrogen to fill out the first things we're looking at. Now, when I say the first things, every mineral is needed and is important. But if we don't have calcium and phosphorus in charge, in the lead, and available, nothing else matters. Potassium, magnesium, sulfur, important minerals. But nitrate nitrogen and ammoniated nitrogen are very important, and I think I can give you some information that you may not have heard before. When we're looking at a soil test, we normally see the nitrate nitrogen levels are higher in the soil for several reasons. Number one, it's the least used nitrogen within the soil because nitrate nitrogen is easier to manufacture for the microbes than ammoniated. So if you look at your soil test and if it doesn't have nitrate and ammoniated separated, please ask for that because there's several reasons. Number one, nitrate will show high, ammonium will show low. This is a problem. If that shows up on your soil test, you have tight soil, you have a deficiency of calcium, you have a deficiency of phosphorus, and you're not getting carbon and oxygen into your soil because the ammoniated nitrogen is created by microbes because the atmospheric air that has 78% nitrogen may not be getting into the soil and having those microbes convert it. Your nitrogen bill should not be your highest input cost if your soil is healthy without disease or impairment. Ammoniated nitrogen is your reproductive nitrogen. Not much of it is needed in the plant until silking, flowering, tasseling, blossoming. But that is when the plant has an appetite, and that's when it needs it right now. Ammoniated nitrogen is not only just the reproductive nitrogen, but it's also the temperature moderator in the soil. If someone were to walk up and have a briefcase full of money, and they open this up, they said, if you can make warm or hot right now, I'll give you $1,000 US. Piece of cake. There's warm. I said, okay, here's your $1,000 US. Now it says, for the $1 million that's left in the briefcase, sitting right there with your bare hands, make cold. That's tough. Now we're going to jump into physics for just a little bit. Ammonia and freon, stick with me, ammonia and freon are both used in refrigeration. Ammonia and freon are weird little elements that have a very unique personality that when you apply heat to ammonia or to freon, they cool down. When you cool them, they warm up. What's my point? If your nitrate and ammoniated nitrogen are equal in the soil, and it gets to be June, July, August, or whatever time of the year that sun is beaten down and trying to cook that soil, if you have ammoniated or ammoniacal nitrogen equal to your nitrate nitrogen, the heat will actually revert, and that ammoniated nitrogen will cool your soil. Cooler soil or a more moderate soil temperature won't get rock hard if you have calcium, phosphorus, air, and you also have the microbes to keep this ammoniated nitrogen going. But there's a twist. If you're an alfalfa grower, you say, well, I grow alfalfa. I don't need ammoniated or reproductive growth. I don't need all that ammoniated nitrogen. Oh, but you do. When you have that nitrate and ammoniated balance, you cut that alfalfa off, you cut that grass hay off, all of a sudden now the sun hits the ground. The more stable that soil temperature is, i.e. ammoniated levels equal to your nitrate, the quicker your regrowth is. And so when you're looking at alfalfa, in this country, we look at relative feed value. Or if you're looking at grass hay, we look at relative feed quality. Well, whether it's relative feed quality or relative feed value, I've asked a lot of growers this. It's like, what's it relative to? The number that you get, and in the U.S., if you're at 160 relative feed value on alfalfa or higher, that's usually considered dairy quality hay. Many people say, well, there's no reason to get it over 200. Well, guess what? There may be a reason. We've got a very good hay grower in Minnesota that you can see his numbers on his hay are quite respectable. But regressing and jumping back, relative feed value, what's it relative to? It's real simple. Carbon and oxygen. You want to get higher quality alfalfa with a higher relative feed value? Get some of this atmospheric air into the ground, because it has to cycle into the ground to get it back into the plant. If you want grass hay with a higher relative feed quality, get the air into the ground, the carbon, the oxygen, the nitrogen. Mother Nature and Mother Earth are both female sectors of reproduction. And I believe Mother Earth or Mother Nature has to be taken care of. And if you give her what she needs, she will say thank you with healthier soil, with healthier plants, and lower input costs. Many years ago, when I was in the livestock industry, I had an old German nutritionist that told me that calcium was one of the most limiting minerals in all animal production facilities. I had another German professor years later tell me that almost everything in the world has a calcium deficiency. Wonderful statements to make, but how do we know if they're true? If your soil has more than 200 psi pressure, if you have lumps, clumps, clods, hardpan, and have more than 200 psi pressure in your soil, you have a calcium deficiency. If you have weeds, disease, or insects probably your soil, you probably have a calcium deficiency. Wait, you do have an available calcium deficiency. Now, when I talk about calcium deficiency, a lot of soil tests will show up that have all kinds of calcium in the soil. Great. how much is getting to the plant. So what we're looking at is in your soil, if you can't translocate that calcium and phosphorus from the soil to the plant, it isn't doing you any good. You're not going to have water penetration, you're not going to have carbon sequestration, and you're not going to have a healthy plant. 2% calcium, 0.3% phosphorus is the minimum level plants need to sequester carbon, to become disease-free, and to outcompete weeds. Now, when I say weeds, this isn't the definition that the professors give, saying a plant growing out of place. Jay McCaman wrote a book, When Weeds Talk. Jay McCaman's book separates the plants. Food-growing plants enjoy available calcium, available phosphorus, available carbon, available oxygen, and they love having beneficial aerobic soil microbes massaging their roots while they're growing. Weeds are a whole different critter. They're part of the scumbag family. And it isn't just a plant growing out of place, it's growing exactly where it needs to grow, because weeds do not like available calcium. Weeds do not like available phosphorus, they do not like carbon, they do not like oxygen, and they do not like beneficial aerobic microbes massaging their roots. If your weeds are outgrowing your crop, or if you have super weeds, or you have chemical resistant weeds, you've got screwed up soil. I'm sorry. Wait, let me back up. You don't have screwed up soil. You don't have super weeds, but maybe your neighbor does. If your neighbor has super weeds and chemical resistant weeds, your neighbor has screwed up soil. He is lacking, or she is lacking, available calcium, available phosphorus, carbon, oxygen, and beneficial aerobic soil microbes. That's the difference between food that is nutritious, that is chemical-free, that is reduced input costs, that is sweet and has insect resistance, versus weeds that are telling you a story. Now, the next time that somebody says the weed is the problem, please stop them. It's the scout. It's the symptom of a problem. The weed is a problem, but tight, imbalanced, poor nutrition soil is what the problem is. The weed is just telling that there is a bigger problem. Insects, many times, are considered the problem. They're a problem telling of a bigger problem. Disease, many times, is a problem. Not the problem, a problem. Weeds, disease, and insects are only indicators telling you that your neighbor's soil is screwed up. Your neighbor's soil is growing weeds and growing insects. It's deficient in available calcium, phosphorus, carbon, oxygen, and aerobic beneficial soil microbes. Now, we talked about available calcium and available phosphorus. We know that if your soil is tight, compacted, lumpy, clumpy, cloddy, you have a calcium deficiency. If you have weeds, disease, or insects, you have a calcium deficiency. If the penetrometer is over 200 psi, you have a calcium deficiency. As we look at calcium and phosphorus, those are the two first minerals you need to work on, because you can't have a home and you can't have a healthy family unless you have healthy parents, and the parents have to be available. So let's get our calcium and phosphorus levels in line, and now we can start sequestering carbon. Let's talk about carbon. Too many companies are talking about carbon in the form of soil organic matter. It's a great number, but we need to go more definite. We need to become more exact in measuring this, because just looking at one element all by itself isn't giving you a true picture. So you want to sequester carbon. Wonderful. We have to start off by looking at carbon to nitrogen because those two have to have a relationship. And this relationship, the carbon to nitrogen relationship, will dictate, regulate, and support the life you have in the soil as long as you have air first. What do I mean by that? We're talking about CO2, carbon dioxide. Carbon dioxide has to be sequestered into the soil and it has to be stored in the soil, but it's actually what you're going to sell down the road as soon as you harvest. But carbon dioxide, CO2, is a wonderful combination. It's a wonderful compound. But please keep in mind that many soils that are tight, compacted, airless, i.e. calcium deficient, may be a little short on oxygen. What happens if you take carbon dioxide and pull one molecule of oxygen away from carbon dioxide? Yeah, carbon monoxide. What happens if you take that last molecule of oxygen, let's just say in tight compacted soil, and you squeeze the last molecule of oxygen off of carbon and you throw nitrogen at it? The agricultural answer to all, carbon with nitrogen in an airless environment can form cyanide. Welcome to modern agriculture. So if you have cyanide in your soil, carbon but no oxygen, and you add little oxygen, you may just get carbon monoxide. Not quite enough. You need to go past carbon dioxide to get more oxygen than carbon. So if you're adding carbon to the soil thinking that's going to help, please stop and make sure your soil can breathe first. In our country, ambulances have EMTs, emergency medical technicians. And these EMTs know CPR, cardiopulmonary resuscitation. They come onto a problem, they come onto an accident. Let's just say it's one of your neighbor's fields. And that field isn't doing very well. It's lifeless. It's not breathing. They need to take vital signs of the soil and or people. The vital signs are, can that soil breathe? Is it under 200 pounds per square inch? If you don't have air in your soil, if that soil isn't breathing, it's no different than us. Nothing matters if we can't take a breath of air. Number one, check for air. See that there's air going in and air going out. That's fantastic. Number two, we need to see if there's a heartbeat. And the heartbeat can be checked very easily with an EC meter, an electrical conductivity meter. This EC probe measures the heartbeat. This EC meter measures the electrical frequencies of nitrate nitrogen, ammoniated nitrogen, salt, sodium, and it also measures other minerals within a certain frequency band, but it also measures the electrical value of microbial soil life. What do I mean by that? Well, let's go back to the human side. Our heart beats 80,000 to 100,000 times a day. What keeps it beating? Don't really know, don't really care, don't really think about it till it stops. We know our heart is electrical because if it stops, the EMTs will juice up the jumper cables and pop us, jumpstart us back into shape. Once our heart is beating, they put us on an EKG or an ECG machine, an electrocardiogram, to measure the electrical impulses. Well, the soil doesn't have electrical impulses, but it does have electricity. You can measure the heartbeat of the soil with an EC meter to see, is the heartbeat strong? Is it weak? Is it too fast? Is it too slow? Is it in the right zone? With this EC meter, it reads from these bottom two probes. As you push this down through the soil, push it down slow and deliberate, watching the numbers. The numbers are what they are, but see how consistent those numbers are, because the more consistent that number is, the better the soil's heartbeat is. The more consistent this number is, the stronger the soil can react to adversities with the weather and with problems in the environment. Here's some hard numbers for you. When you turn this on and you stick it in your soil, in the beginning phases of your plant growth, the plant growth is vegetative or anionic, and the anionic or vegetative electricity on this meter should be a 0.3, 0.4, 0.5. That vegetative or anionic energy is root, stem, and leaf. 0.3, 0.4, 0.5 is the vegetative anionic energy that the plants need, as well as the anionic energy that the microbes are creating to feed that plant the energy. The plant and the microbes are symbiotic and they're helping each other. So we have to have air around the plant, and we also have to have air around the roots for the microbes to create the electricity. Once reproduction happens, silking, tasseling, flowering, blossoming, this 0.3, 0.4, 0.5 that we needed to start the race, the first leg of the race, now gets handed off to reproduction, which is cationic growth. Cationic growth, these numbers should be 0.6, 0.7, 0.8, 0.9. That's the energy that's needed for reproduction, for seed fill, for pod fill, for fruit development, for any plant on any continent, in any country, in any state, in any type of soil. These numbers are valued. If you get to a 1.0 on this meter, your microbes shut down. So there's many things that will negatively dictate what happens. If your reading is 1.0 or higher, the microbes shut down. If your penetrometer is over 200 psi, your microbes shut down. Get the calcium in the soil to open up the soil, and then the microbes can be allowed to do their job. And please make no mistake, calcium and phosphorus are the two most important minerals to us as humans, to animals, to plants, to soil. Please don't forget about the microbes. Microbes have physiology, microbiological physiology, and they have to have calcium and phosphorus for structure just like we do. When you have calcium and phosphorus evenly distributed on an available basis throughout the profile of your soil, the microbes in your soil will have cellular integrity and reproductive capabilities. They have to be strong and they have to be attractive in order to reproduce, and they have to have air. Topically applying calcium to your soil and making sure you have available calcium throughout your entire soil profile is the most important thing for sequestering carbon in the upcoming future. So we're going to sequester carbon. How do we measure it? Soil organic matter is a good number, but many times when they probe your field, they probe down through the stubble, they probe down through the fodder, they probe down through last year's residue, and they count that as soil organic matter. What you should be looking at, and what's more accurate, is look at ratios. Calcium and phosphorus, the ratio 2% calcium, 0.3% phosphorus is a ratio that plants need to make photosynthesis happen. When we're looking at the soil and when we're sequestering carbon, carbon to nitrogen ratio is where we want to be looking at. Now, many professors that I've talked to in this country, I've asked them about carbon to nitrogen ratios, and they'll go, oh, shoot, you probably have 8 or 10 times more carbon in your soil than nitrogen. And they're right, because that's what most soils are, is an 8 or a 10 to 1. Not good enough. Aerobic, air-breathing, beneficial microbes at an 8 to 1 are just there. We may have had employees like this. They show up, they're there, but they're really not getting anything done. If you want these microbes to be efficient and to work for you, you've got to have a 16-to-1 carbon to nitrogen ratio. Now, the NRCS, National Resources and Conservation Service in the United States, put out some really great information that 8-to-1 carbon and nitrogen, those microbes are just hanging out, surviving. They're not doing much. They're just being subsistent. 16-to-1 carbon and nitrogen, they're partying, they're reproducing, they're making things happen. They're sequestering carbon, they're fixating nitrogen, they're feeding and protecting the plant. 18 or 20-to-1 is when mycorrhizal starts showing up at the party. Mycorrhizal fungi, the beneficial fungi that you probably heard all kinds of wonderful things about. All of those things that mycorrhizal fungi do is true, but if you don't have an 18 or 20-to-1 carbon to nitrogen ratio, they're not going to be happy and they're not going to work efficiently for you. And the last number, 30-to-1, is what good compost is. 30 times more carbon than nitrogen is a perfect scenario. Weed-free, disease-free, wonderful, nutritious, immunity-giving, longevity-producing food can be grown in a 30-to-1. Now, you check your soil and you see you're at a 10-to-1. You're like, oh, this is not good. How are we going to get all the way up to where we need to go? Well, you don't need to be all the way to 30-to-1. But if you have excess magnesium in your soil, here's something fun that can happen. When and if you apply a good, clean, available calcium, that calcium, being the mother, sees this compacted, tight environment, and with rain will penetrate the soil, and all of a sudden it'll see magnesium as being kind of a problem. And calcium, being a good mother, will electrically grab onto magnesium, which can naturally happen. It forms dolomite. Calcium and magnesium form dolomite in the soil. When magnesium is in excess, calcium has a natural attraction to it. And the calcium will come up, it'll give the magnesium a hug and say, now you let go of that nitrogen. And all of a sudden, poof. Now the nitrogen that your fertilizer guy says, it's not available. Oh, it's tied up. The nitrogen that your fertilizer guy said, it's all tied up or it's not available, all of a sudden now becomes available. And what else happens is your carbon to nitrogen ratio that was, I'd say, an 8 or a 10-to-1, not by increasing the carbon, but by reducing the nitrogen, your ratio now went from, say, a 10-to-1 to a 12 or 13 or 14-to-1, and now you've got a leg up getting closer to that 16-to-1, which is where you have to be to become efficient, to become carbon sequestered, to have efficiency in water, and to reduce your fertilizer and chemical bill. The other thing to look at is when you're looking at your fertilizer bill, remember we talked about calcium has a substitute, not a good substitute, but a substitute mineral of potassium. If calcium isn't available, the plant will grab potassium and you'll get a watery, washy plant that doesn't have any immunity. Well, a plant wants to be made of carbon. But if the carbon and oxygen that has to be attached to the carbon isn't there, it will take nitrogen. So, if your nitrogen bill is a little too high, I'm going to bring in another tool here, the common refractometer, and the even more common, you guessed it, garlic press. Grab some tissue of the plant, usually in the center of the plant, top to bottom, right in the middle, and squeeze a few drops of juice out on here to see what the sugar content or the refractive reading of your blood or the liquid or the sap of the plant is. If you are below 8 bricks of sugar on your plant, you will be susceptible to detrimental disease-causing fungus, algae, and mold. On the other side, if you were to check the sugar content of a weed, Most weeds don't like getting up to that 8 or 9 bricks of sugar. Most of them in that 4 or 5 range. So to sequester carbon, if you don't have a good refractometer reading, the carbon cycle isn't properly cycling in your field. We talked about 8 bricks being the threshold of detrimental fungus, algae, and mold. 10 bricks of sugar or more is normally the cutoff point that weeds stop growing. To get 10 bricks of sugar in your plant, there's 5 things you have to have going for you. You have to have available calcium, you have to have available phosphorus, you have to have available carbon, you have to have available oxygen, and you have to have beneficial aerobic soil microbes. Those 5 things are a must. If you haven't seen a change in your refractometer, and many people haven't, one of the biggest comments we get, people say, oh, we've been doing refractometer readings for 15 years and we've never been able to change it. They're missing 5 things. Yes, available calcium, available phosphorus, organic carbon, oxygen, and beneficial microbes. Weeds do not like a sugar content of 10 bricks or more. When you get your calcium, phosphorus, carbon, oxygen, and beneficial microbes going, they create the environment that builds sugar, that creates photosynthesis, that sequesters more carbon out of the atmosphere, that sequesters more nitrogen out of the atmosphere, that allows water penetration, that allows the high pressure fronts to sink in and low pressure fronts to exhale. That's the carbon cycle all working together. And the last great number, once you get to 13, 14 bricks of sugar, you now have natural insecticidal resistance. What do I mean by that? Plant-feeding insects don't have a pancreas. The high sugar content of 14 bricks of sugar will ferment, turn to alcohol, and kill them. We had that verified by a doctor of entomology, Dr. Tom Dykstra from Florida. He told us that microbes carry about 1/2 of a volt of electricity in their body, which can be measured with an EC meter, and they also do not have a pancreas, and sugar is a natural insecticide against any and all plant-feeding insects. So the fungicides, the herbicides, the insecticides, the pesticides that you have all can be replaced and can be farmed with less or none just by getting your soil healthy. Available calcium and phosphorus starts the process and gets everything going. When we talk about carbon sequestration, let's narrow that down a little bit more and just talk about carbon. There's an entire science that has been built and studied, organic chemistry. Organic chemistry is a study of carbon and everything that carbon hooks to. It is the essence of life on Earth. And this carbon isn't just meant to go into the soil and be stored. It's to go into the soil and be utilized. Some of it will get stored, some of it will be used as fuel. But this carbon is the backbone of agriculture. And one of the major reasons the carbon isn't being sequestered is because of compacted, tight, airless soil. So when we look at water efficiency, when we look at water absorption, when we look at water penetration, the calcium has to open up that soil in order to allow the water to go in. But now that we're looking at in the soil, carbon is a fantastic element. Carbon can form more compounds than all the rest of the minerals or the elements on the periodic table combined. What's my point? Carbon is a friendly little element. It wants to get along with everybody. And carbon loves water. Carbon will hold 4 times its weight in water. If you want to increase your water efficiency, get the carbon level up in your soil. But you have to get the calcium there to reduce the surface tension of the soil before more water can be stored. So think about this. The higher the carbon to nitrogen ratio in your soil, the more water it will hold. The higher the sugar content or carbon content in your plant, the more moisture that will hold. So increasing the carbon content in the soil, increasing the carbon content of the plant, you will have a higher efficiency of water in semi-arid regions where water is either scarce or it's expensive. There's three things we need to look at very carefully. Number one, we need to get the penetrometer so this air can go down deep into the soil. Number two, we have to have the carbon there to hold that water in the soil. But most importantly is we need available calcium to allow it all to happen. In drier agricultural farming areas, water is always a priority. The quickest, easiest, cheapest way to increase water penetration is allowing calcium to be applied topically so it can work down with the water. Calcium needs to be equally and evenly distributed throughout the profile to allow water to penetrate and be held. This opening of the soil or the relaxing of the surface tension of the soil is also the same thing that you need to sequester carbon as well as nitrogen from the air. As you get your carbon to nitrogen ratio to an acceptable level, 16:1 or more, you now have more water holding ability and you now have more sugar building ability. The carbon cycle is now starting to happen. And as this carbon cycle is moving, the healthy soil will start to generate a healthy plant. And what that means on a water situation in irrigated semi-arid areas, when we get to 2% calcium, 0.3% phosphorus, and at least 10 bricks of sugar, we have anywhere from a 30 to 40 to 50% reduction in irrigation costs. I realize you don't have irrigation where you're at, but it's making the efficiency of your water by using good, clean calcium, opening up that soil, making sure you have a good carbon and nitrogen ratio, and getting the carbon cycle to happen, and that will bring forth a healthy plant, which is our next topic. I've asked a lot of growers around the world what their plant is made of. And many times it gets really quiet. And I say, I don't mean to be a smart jack, but if you guys don't know what your plant is made of, how do you know how to make it? Knowledge is power, and power rules the world, and the information that you possess is dramatically important, because if someone comes up to you and starts talking about something, if you don't know enough to know whether they're telling you good or bad information, all it is a waste of time. So, what is a plant made of? A lot of guys will say, well, we hear you talking about calcium and phosphorus all the time. There must be a bunch of calcium and phosphorus in there. It's like, yes, there is. But let's go to a green growing plant that's in the field. Most green growing plants are 70, 80, sometimes 90% water. Water's a variable, which we all know. So let's take the water out. And let's just say it's 80% water, so we have 20% dry matter. We're getting rid of the water. We're looking at it on a dry matter basis. Now, the 20% dry matter that's left that we harvest, and this is very consistent through the roots, through the stem, through the leaf, and through the seed or through the plant. The 20% dry matter that's left, considering total volume of the plant in the field, what's that 20% made of? I purposely paused because I wanted to give a little bit of thought. If you don't know what it's made of, it's going to be hard to kind of make it. So, let's go back to what we know. If you have a healthy plant, and if that plant was able to grab enough available calcium and enough available phosphorus, and it had enough available carbon and oxygen, and its roots were being massaged by aerobic beneficial microbes, if all that's happening and the plant is healthy, in the dry matter portion of that plant, 47% of that dry matter in the plant, that plant wants to be carbon. 47% of the dry matter, if the plant has what it needs, that plant wants to be carbon. 43% of that plant wants to be oxygen. Okay, we're at 90%, and we just covered two elements, carbon and oxygen. Wait a minute. What are we trying to sequester out of the atmosphere? Oh, carbon and oxygen in the form of carbon dioxide. See how this all works together? If the soil can get the air will supply the soil, which supplies the microbes, which supplies the plants, which also supplies your checkbook with efficient, debt-free farming. So on a dry matter basis, 47% carbon, 43% oxygen. I'm going to run through the numbers, and then we'll go back and individually look at them. 47% carbon, 43% oxygen, 4% hydrogen, 3% nitrogen, and the last remaining 3% is all of the soil minerals that show up on your mineral test of your soil. So, if you get all the minerals in your soil perfect according to your soil test, that only makes up 3% of the final product that you're going to sell. So if you're looking at base saturation, fantastic numbers. Keep in mind, it's just the base. It's just the foundation. It's just the beginning. So as we look at carbon, where can we find carbon? Well, if we have microbes that can breathe in air, they'll give off carbon dioxide. This carbon dioxide is what feeds the plant. Now, speaking of carbon dioxide, I'm going to jump into a very almost taboo, touchy topic, tillage. A lot of people say, do not till your soil. Tillage of the soil will destroy the microbes. Tillage of the soil will lose all this carbon dioxide. You'll lose all these things. They're not telling the whole truth. And they're not telling nothing but the truth. If you have air and oxygen in your soil and microbes can take carbon and oxygen to make carbon dioxide is 1.5 times heavier than air. So tillage will not lose carbon if you have air there. Now, if you are a no-till or are a minimum till and last year's crop is made up of carbon, oxygen, and all the things we just talked about, and it's left on top, and it is not incorporated, and it's just left out to the infrared and the ultraviolet rays of the sun, carbon and oxygen are usually two of the quickest things that will oxidize and leave you. And 60 to 70% of the carbon that's in the residue that's laying on top of the soil is in a form that is lighter than air. So, if you do not want to sequester carbon, leave your residue on top of the soil. If you want to sequester carbon and build carbon in your soil, it's kind of like having lunch. If you're a no-tiller, and when you go to dinner tonight, you don't need a fork, you don't need a spoon, you don't need a knife. You're going to lay down on the floor after you get your plate of food, unbutton your shirt, and flop your food on your chest and on your stomach, and osmotically it will absorb into your stomach, and you will become nutritionally satisfied just like that. That's what you're expecting your field to do. If you want your soil to digest the carbon and oxygen that you grew last year or the year before, that has to get into the soil. The residue has to be in the soil. The air has to get into the soil. So soil porosity for water penetration, air penetration, all has to be there. That's why the importance of making sure mom is there. Mom being calcium, opening up the soil. Once that soil is opened up, and when I say opened up, it may be some form of intelligent tillage. Now, the erosion and the blowing that they talk about and are concerned about, that is real, fellas. No doubt about that. Please do not jump into any aggressive tillage. But you do need to do some incorporation of this residue in order for digestion. 60 to 70% of the carbon that's in your residue from last year will be gone due to oxidation and natural lightness of the carbon. It will go up, up, and away. When that carbon leaves you first and the oxygen leaves you first, then the calcium will oxidize, the phosphorus will oxidize, the magnesium will oxidize, the sulfur will oxidize, the nitrate nitrogen will oxidize, the ammoniated nitrogen will oxidize, and you'll be left with one mineral left in that residue. You know what that one mineral is? Potassium. It got a name, potash. Nickname of potash. Anything flammable in a fireplace or in a stove, wood-burning stove, every mineral will oxidize, give off BTUs, and go up the chimney. And when everything is burnt, and everything has been expelled, and everything has been extracted out of that, and the fire goes out, you're left with what? Ash. Pot ash. Guess what one mineral, which when it's in excess, does? It gets the weeds talking and it gets them growing. Potassium when it's in excess. And if you have more potassium in your plant than calcium, you have an unhealthy plant. When you have a lot of potassium in your soil, you're going to grow weeds. When you leave the residue on top of your soil, you end up with potassium, i.e. potash. You end up with a higher chemical bill because you are feeding the weed. Weeds do not like available calcium. They do not like available phosphorus. They do not like available carbon and oxygen, and they do not like beneficial aerobic soil microbes. Weeds love potash. Weeds love potassium. Weeds love no-till. But, oh golly, you've got soil armor. You've got that residue that's protecting the soil. Many times the water is held in the trash, the residue, or the mat of undigested residues from the crop. That water never gets to the soil. What a healthy plant is made of. You don't hear much about this. It's kind of tough to read it because it isn't something that is readily put out there. If you don't know what a plant is made of, how do you know what it needs? I have just a few books here from a large collection that I bought many, many years ago. And these books date back to the 1850s. And the books that I found to be the best were from the mid-1800s to the early 1900s, before all the fertilizer companies came in. And in 1855 is the earliest book I found published that it talked about what a plant is made of, a healthy plant is made of. But we don't hear about what a healthy plant is made of because that isn't where the big companies make their money. They make their money off reacting to symptoms of sick plants. This is why we want to talk about what a plant is made of. Because once we know what it wants, then we can give it what it needs. A plant wants to be made up of carbon and oxygen. When you think of carbon, please think of oxygen in the same sentence. Never, ever, ever isolate those two. Calcium and phosphorus have to be together. Carbon and oxygen have to be together. So when you're looking at carbon and oxygen, 47% carbon, 43% oxygen is what a healthy plant wants to be made of. Where can we find that? Well, number one, with available calcium and phosphorus, you can get photosynthesis. With available calcium, you can get air into the soil, and that air gives life to the microbes, and they give off carbon dioxide. Now, this carbon dioxide, they say, well, be careful, do not till, because you will lose this carbon dioxide. Well, carbon is one of those minerals that likes to grab onto a lot of different things. And carbon, when it's in the plant from last year's residue, fodder, or stubble, most of that carbon, 60 to 70% of that carbon, is lighter than air and is easily oxidized and will go up, up, and away and leave you. If you can take that carbon in the form of residue, incorporate that into the soil, and have a microbe take that carbon and add it to 2 oxygen molecules, i.e. CO2, carbon dioxide, the carbon that was in the residue that's lighter than air, once it becomes carbon dioxide, is now 1.5 times heavier than air, and it won't leave you. And this carbon dioxide has to be exhaled, 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 exhaled up by the microbes in order to get it to suck back in through the stomatas on the bottom part of the leaf. What we found is many, many years ago, we did a carbon sequestration test. And this is probably 30 years ago that we did this, where we had carbon sensors. And what we watched is over the night, the carbon level slowly came up and different sensors would light up. And then all of a sudden in the morning, we'd be at the full height, and we were using soybeans as a plant that we were measuring the sequestration. But the carbon would rise up to the top of the plant, and that's all the further we tested. It may have gone further, but all of a sudden, boop, it just disappeared. And it took us several days to realize that as soon as within seconds of the first morning sunlight hitting that leaf and photosynthesis, bam, that carbon dioxide just got instantly, within nanoseconds, sucked into that plant if we had 2% calcium, 0.3% phosphorus to start the process. If the calcium and the phosphorus weren't at adequate levels in the plant, 2% calcium, 0.3 phosphorus, the carbon sequestration did not happen. The calcium and the phosphorus has to be in the soil, it has to be in the microbe, it has to be in the plant in order to sequester the nitrogen and the carbon from the air. A plant wants to be made up of carbon and oxygen. So if we take a look, 47% carbon, 43% oxygen, that's 90% carbon and oxygen. A plant only wants to be 3% nitrogen. If your nitrogen bill is too high or higher than what you like, nitrogen is a poor substitute for carbon and oxygen. Just like potassium is a poor substitute for calcium, nitrogen is a poor substitute for carbon and oxygen. So you want some carbon credits? Get your carbon and oxygen in the soil up. Your nitrogen bill will go down. And here's what I mean by that. I told you at 10 bricks of sugar, weeds start getting weak and going away. Well, here's something else that's really cool. At 10 bricks of sugar, you start seeing water savings, which we talked about, 30, 40, 50% water reduction. But here's one other thing that happens. At 10 bricks of sugar, the level of nitrogen that you were using in the past can now be cut in half. I'm going to say that a different way. At 10 bricks of sugar, your nitrogen bill can be reduced by 50% when your carbon and oxygen levels have increased. and that can be measured with a refractometer. So at 10 bricks of sugar, your nitrogen bill goes down, you have increased water savings, and you also have weed resistance. Carbon and oxygen need to be 90% of the dry matter weight of the plant. So when we look at a healthy plant, carbon and oxygen being 90%, nitrogen only being 3%, doing the math, that's a 30-to-1 ratio. What's good compost? According to the NRCS, 30-to-1. I wonder if that's that carbon cycle that they taught us in 8th grade. Carbon is the essence to life. Carbon is what saves you money. Carbon is what makes you money. And by opening up your soil and checking the surface tension and getting the carbon cycle back into your soil and into your plants, you will receive carbon credits. You'll receive carbon credits like you've never seen before. You can reduce your nitrogen, you can reduce your fertilizer, you can reduce your chemicals, and you'll have a higher efficiency of water. Sometimes people will say, well, how do we know carbon actually hangs on to water? It's like, well, carbon is one of those wonderful elements that is needed in many different things. Carbon many times is used as a filter for water. Have you ever seen a filter that is made of carbon in a pitcher? Or a filter of carbon that you put on your faucet? Or a carbon filter that you put on your shower head? It's a filter of water. Another way of carbon, when you look at carbon and sugar, is basically carbon, hydrogen, and oxygen. Carbon in sugar gets hard if you leave it on the counter for some time. Now it may be in a plastic paper lined bag, but left there long enough, that sugar gets hard. What makes it hard? Water. Where does the water come from? The air. What do we call that? Humidity. Even in a low humidity environment, a good, respectable 10 bricks or more sugar content in the plant, that plant will actually extract moisture out of the atmosphere, and the same thing holds true for the soil. Carbon holds 4 times its weight in water, and getting the carbon into the soil from the air is the first step to getting your soil healthy. And let's make no bones about it, fellas, it's hard to grow a healthy plant out of sick soil. We've got to fix the soil, and anything good in life has to breathe. Many people talk about chemical resistance, superweeds. The bigger, the pricklier, or the nastier a weed is, the more out of balance that soil is. It's just like if someone is ready to step off a cliff or step in front of a truck, you go, hey, don't do that. And they keep on walking. It's like, hey, don't do that. And they keep on walking. The volume is going to get turned up. Mother Nature's no different. They start off with a little weed, and that little weed is in its own little way saying, hey, the soil isn't very good. You don't hear it. The next year, it's a bigger, nastier weed. It's like, hey, this soil isn't doing very good. Several years down the road, here's this big, nasty, prickly, horrible weed going, your soil is screwed up. And here comes the chemical bar. Mother Nature is asking for some love. She's asking for some kindness. And that goes back to common sense. Common sense isn't as common as it used to be, but hopefully we can start turning the ship and start creating a more natural, healthier environment that grows inexpensive, immunity-building food. And it can all be done with the program that we have encompassed here. Everything that we have spoken of, we have been practicing for over 20 years. This program works on all crops that are sun-loving, that are photosynthetically producing sugar, and grow in dirt and or hydroponics. So no matter what country, what continent, or what crop, this program will work for you. The reasons I look at these old books is because information from these books was printed before there were fertilizer and chemical companies trying to sell us stuff. This particular book was printed in 1855, and the author is John P. Norton. He's a professor of scientific agriculture at Yale College. And he talks about the organic elements of plants. And if I may, I'd just like to read to you a little bit. And this is in the old, wonderful English that used to be spoken. But he starts off, this chapter is, the organic part in plants is by far the largest, as is plainly to be seen on burning any form of vegetable matter. It ordinarily constitutes from 90 to 97 pounds in every 100. During the burning, this solid organic matter disappears. It is driven off into the atmosphere until nothing but a little ash remains. That which has gone, then, has evidently become air. It is easy to see that this part of the plant can easily and can only have been formed from air at first. Such a conclusion may seem very strange at first. I wonder if John was a disruptor. I'm sorry, I'll go back. Such conclusion may seem very strange at first, but a little reflection will show that we can arrive at no other. When we have made up our minds to this, it becomes important to know what kind of air it is that forms so large a part of our plant, or is there more than one kind of air? They knew this in 1855, and he goes on to tell the exact numbers that I told you in 1855. So if 90 to 97 pounds out of every 100 is comprised of the air, why do we need so stinking many chemicals and fertilizer? Aha! You already have the answer, because the air is no longer getting into the ground. The air has to get into the soil so we can have the carbon cycle. Some of these things that we have talked about may be new, may be different, may be crazy. And you're wondering, well, I've heard this speaker talk about this, I've had this bald guy from South Dakota talk about that, who do I believe? Don't believe any, but please do your own research. If you have a phone, you can Google anything. Google what a plant is made of. Google what a healthy plant is made of. Google what insects like and don't like. Start doing your own information, because if you don't have a high level of working knowledge of what your soil is and what its capabilities are, you may not know if someone's telling you the truth or not. And if they're not telling you the truth, the whole truth, and nothing but the truth, they may not be your guide. I apologize I wasn't able to go to the depth that you may have liked on any of these topics, but our time was limited. If you do have comments, concerns, or questions, please look us up at soilworksllc.com. Email us, send us a note. We would love to hear from you. Positive criticism, bad criticism, questions or comments. Hopefully this information was valuable and will benefit you in the future. And again, thank you so much for your time.